Hey everybody, this is Brad Dyke saying hi, and we are at a point where we are able to begin to re-diagnose the R720 Dell DX motherboard platform. This is in regards to a bad pin set that I had gotten from my replacement board. And as you can see here, I have a new motherboard here, which I just bought, and I've inspected the ports, and they all look good. And that's important to me because the other one, which is right over here, is bad. You can see it right there. There's a pin right there. It's been bent out. And so the company even knew that they had sold me a bad one because they just let me have this motherboard and just refunded my money. So I'm in the process of now going ahead and preparing the motherboards here. And unfortunately, because of the fact I have to have two hands, I'm going to have to temporarily stage this to a certain point without a camera. But I just wanted to show you what I've got here. They ship filler CPUs, which are the series 5320s or 40s, which are your basic common Xeon processors, which are really good Xeon processors, especially for workstations. But I've got 12-way processors for this, and they're already in that system there, the 80 series, and they are going to give me more firepower for what I want to do because this is a multi-construct system. And so hang on a second here while I transfer the RAM real fast. Okay, so I've taken the memory out of the board. And basically, this board is pretty much gutted. And then over here, I've got my memory transplanted correctly. And if you know anything about these motherboards, if you're going to do anything with the memory, do it separately, not when you're doing transitions such as whole motherboard transplanting. So with that being the case, I'm going to move this motherboard into its home on the other rack next, and you'll see that go into its casing. Okay, so we've got the memory installations done. We've got the board in. Everything seems to be looking good. There we go. I got the SAS cables connected up. Bridges are set. Right. I had one cable come out. I think I got it right. It was right down here. Popped out of its socket seam, which was not good, to say the least. But the real test will be when I put this guy in and make sure that it snaps in correctly so that my RAID controller comes up. I'll post only that for now, and then I will continue to do my other testing. So let me put the fan assembly in. Just take a second. Again, it takes two hands. But, you know, this guy right here, this is the RAID controller. I can go ahead and preset him. But it does take two pressure points to properly seat it into its home. And there it goes. Yep, that's flush, and it snapped in easily, unlike the other motherboard, which it did not. So with that being the case, I'll put the fan assembly in next and get that in here and make sure it's lining up correctly. I think I'm going to have some problems with this because it was a snap-on and I don't think it went in the right way. But it shouldn't be a showstopper. And then I can assemble the rest of the units here at the 10 gig NIC and so on and so on. So let me get the fan assembly put in and we'll get that set. Okay, we got the fan assembly in place. That is good. Then I've got my 10 gig NIC. That needs to go into play. I'm going to have to make sure that it sets correctly and that it is flush correctly. Because if it doesn't, it will not snap in the right capacity. Hang on a second. Alright, the 2 gig NIC is in. That is good. I'm going to put this crazy thing in just for the grins, as it does enable some features in your BIOS. It's an SD RAID 1 boot unit, which is, you know, actually I think I'm just going to keep it out for now. Keep things simple, if you know what I mean. And then we'll go ahead and put the bridge riser card in. That is good. I'll put the secondary one in. Make sure it's setting right. Good. Now, remember that these two buses are actually just one, unlike this one, which is actually an independent one. This is why the NVMe card did not come up correctly on these two, because they're split in time, and so they have problems with running within the actual configuration of the NVMe card. Now, I've got an NVMe card here, so it's already installed, and I can always pop it out if I want, plus my USB 3.0. Great little add-on for all servers to stick these cards in, because they really do incredible things for you when you need to do them. I need to make sure that both my paired RAID controller cards come up. My LSI RAID controller, which is this one right here. I'm going to put him back in because I need him no matter what for external storage capacity. So now I'm going to go ahead and put this guy back in. Alright, how'd this go in? Okay, got it backwards. Come on. Really? What a pain in the butt. I guess I gotta make an adjustment for that. Looks like part of it broke off. It's been used a lot, so that's okay. But I understand. So what I'll do is I will try to get it back in play. Come on. You can do it. Yeah, see right there? Yeah, right there it's not going in correctly. Okay, we've got that back into play. The spaces are working. The only thing I need to do now is to put the processors in, so let me go get those real fast. Okay, so we've got the CPUs transferred now. You've seen all of this before. This is just old hash, that's all. And then we're going to put the heat sinks on. Make sure that they're set correctly. Yes, okay. Alright. Get those fastened down. I'll start securing those down really good. 4 to 8 turns on average works pretty good. You'll start to hear a squeaking noise. There it is. And that pretty much gives you clear indication that you are tightening down, which is what you want. And like I said, that little guy right back there, he had a pin come out. So he worries me a little bit because it could cost me the chassis if it's like an open ground or something like that. So I have to be careful my next few steps. I'm hoping it's just a dead LED or something like that, but you only know until you find out, right? Right. Alright. So the big thing right now is to just do the post test and the configuration side of things so you can get it to work. I have to put a splice cable over into my console so I can get proper hookup. And remember, you want to turn the screw until it locks into place. And there, I just did. check these. Oh, that's still a little loose. The compression does matter, by the way. I think the back is good. Nope, no, it's a little loose too. Alright, now it's tight. Alright, so now we've transferred, we got to the new motherboard. I don't even know if this thing will even post. But we're going to find out here in just a minute. I've got to go ahead and run the set cables, so I've got to drape a cable over and get that set up real fast, and then we'll resume. Okay, so we've got our set in play. We are getting a positive light on the power supply, so no indications yet of an issue. I'm getting some other basic traffic. I'm going to go ahead and secure the lid really quick. Hang on a minute. Okay, so I have gone ahead and placed systems in play. Yeah, I'll put that in. And I'll put you in. Alright. So 2 SSD drives have been put in. All others are inactive. So now we have to wait for the post-configuration diagnostics to run. It requires 2 boots. I also have not yet put in my airflow control. That's this right here. It's not a big deal at the beginning. I'm just looking for basic functionality. So hang on here a second. Raise this up and you can see me towards the console. I am coming up with a post set. Hoping that we will get okay on the diagnostics. I am reporting a signal. There we go. Alright, it finally posted. Good news. SAS controller is coming up. There is no boot process for the environment yet at this point in stage. So it's going to go through the live configuration management setup. Yep, there we go. That's what I'm looking for. Bingo. Okay. We got it. Okay, so what I've done now is I went ahead and initiated, since I see the RAID controller, which is the whole reason why we had to replace the second motherboard. I'm happy. I also see the SAS controller, and I'm seeing some other configurations as well, so that's all good. So now what I'm going to do is I'm going to put the air vent system back in. And this is used to regulate the airflow. And of course, it's going to be a pain. Of course. Why not, right? Now let you see what I'm saying. This is the airflow right here. And it gets a little dense in here, you know? So you have to kind of help it along. It doesn't want to fall in place freely. And that is a little bit of a pain in the butt. So let me see what I can do here. Yeah, it's tight in there. And it shouldn't be that tight, in my opinion. Why is that the case? Huh. Don't like that. Tension is a little strong there. But it did close. So let's put the lid back on. Yeah, it's snug. It's not snug like a bug in a rug. It is tight. Yeah, that could be a potential problem. Yeah, it's not giving proper clearance. It's pushing up. Yeah, right there, I can see it. That might be my problem right there. Okay. Let's see if it is. No, it isn't. Okay. That's the problem with plastics, is they don't play well when you start adjusting things, and they fight you. Pain in the butt, let me tell you. Alright, so let me go ahead and adjust this out. Power it back up. And I'll let you sit on standby here. So, with that being said, it's important to understand that you've got a little bit of a challenge here when it comes to how you want the system to react, right? So, what you do is you really want the system to be able to do what you want, right? Post it, load it, and by doing it in that format, the device will scale. Now, unfortunately, a lot of times that won't happen. And the reason why it won't happen is because of a cute little trick that happens based on compatibility. So here you've got a 3.1 USB drive, very small little gadget, will not work at all. Here you've got a 2.0 and it jives like a baby. It works just fine. There are no issues with it. I'm pleased with it. It works. So with that, I'm going to have to clear the RAID controller first. So give me a second here. Okay. Ah, look at that. That's not good. That might explain a whole bunch of things. So basically, let me show you what I'm talking about. The supplement state of the controller has circumvented the state of the drives, as you can see here, and that caused an immediate issue, or flipped the SSD drives only as cache devices. That's wrong. Now my H710P shouldn't have done that, but it did. So what does that basically mean in a nutshell? Well, what it means is that I've got a problem with being able to actually use my boot state drives the way I want. The boot state drives are going to be high performance drives because I want it to come up quick, down dirty. It's small, it's only like 120 gigs, but I want it to be able to get to the place where I can allow me to get the environment up and running correctly on the SSDs to boot. So this might explain some of the NVMe problems too. So what I have to do now is need to use the right keyboard. Okay. So, what I have to do is I have to destroy the configuration from the BIOS side of the equation. You can't use the local onboard controller chipset because it's going to fight you. So I'm going to have to boot it into the BIOS, get into the BIOS, do state configuration check, and then go in there and delete those cache drives out, because the R720-DX actually is able to run with 100 gig SSD drives that are industry level, and they're very thick and they've got a lot of shielding on them, and they stay very cool, but they act as the buffer for your hard drives. And that's how they cheated the system. That's how they got the performance levels they wanted, by using SSD drives as a dumping ground for the network connectivity or the SAS connectivity for the drives. So by doing that, they can still use the lower end drives, pass it off as high end drives, and sell you an expensive piece of hardware that's really only expensive because you have the SSD drives. What I'm trying to do here is I'm saying no SSD drives as cache. Use SSD drives to boot. Make sense? Alright, so let me go through that process real quick. Okay, so we're able to get it to post correctly. And it's seeing everything correctly, which means this is the actual success. That being the case, obviously I'm not going to put this server in the rack, because as soon as I do, something's going to break, right? That's the way it works. But I inevitably still have to do that anyways, so unfortunately, with that being said, I'm going to have to make the next step be basically prep an operating system on it just to get the basics going, and then I can start the diagnostic processes of adding the new SSD arrays into the equation as well. I have quite a few 1 terabyte drives that are spinning disks, but I don't want to bring them into the fray just yet. I want to keep them kind of separated until I know all the SSDs are working right. And what would be even better is that the SSDs are working right and the NVMe is functioning as well. But that's a whole new set of diagnostics that I'm going to have to go through to get that to work. So what we're doing right now is we're going to do a post set to see if we can get that to happen next. Okay, so what I'm doing now is I'm allowing the device to do full discovery. And that's what's happening here. It's identifying and repaginating the interfaces. It sees my PERC 310. It knows the 710 is right there. It's doing the functional discovery. It's also breaking down all the memory that I have on board, running through a detection set that will allow you to accomplish what you're looking for, and that is to register all your devices and then set them up for a life cycle. After this, it should reboot, and then I'll be able to get into the boot manager and see if I have detection or not. The UFID process, or the UF, whatever it is, IE, I forgot what the process, the acronym is for, but anyways, the ability to boot into a secure boot mode should now work, because I tricked it and made it treat the SSD like it would treat a spinning disk. Now, I'm going to have to run a performance check on that using Crystal Disk Report to make sure that I don't desynchronize the channel. Now, if that happens, because I have SSDs crossing 2 channels in a single group, then I know that my limitation is going to be 8 drives in the first channel, because I have 24 disks in 3 channels. So, with that being said, that's okay. I mean, it just means I have to spend more money on higher capacity SSD drives, but saturating the controller bus is just that. You're saturating the controller bus. And you don't want to do that if you're going to avoid it, that is. Alright, so we're going to just see if we can get it to boot off the USB. Okay, so it failed. Let me go ahead and swap the connector. Hold on a minute. Try it again. Okay, hang on a minute. Alright, we're going to give it another try. Oops. Okay, so, alright, that worked that time. Alright, so it's booting off the USB drive. Now this is 2019, which this server works very well with. No issues there. I may be forced to install the operating system of 2019, but that's not really my mission statement. My real mission statement is, do I see the 500 gig NVMe drive that I've got set in the system? Now, remember that you can't put NVMe cards in a split PCIe bus. That's where a server will actually try to... It makes it look like you've got 3 channels, but actually you don't. You only have 2, period. That's why PCI 3 is just that. It's just 2 channels. So you have to put the NVMe on a single channel that is not split, because there is some logic that runs on that process that can be problematic because it times out and delays, which is not what you want. Now, what I'm doing right now is I'm just using the operating system to see if I can detect my disks. Now, I've got a RAID set on there, and I might choose to allow 2019 to install to a point, and then at that point I would be able to turn back around and again try to troubleshoot the NVMe to see if I can get it to post. But right now this will be the test coming up. Guess what I see? Let me put it in here in prospectus. Check that out. 512 gigs. Hot dang. So I was able to get it broken. Yay! Remember what I told you about thinking outside the box? Amen. That is good news. So I'm going to go ahead and give some instruction here. I'm going to delete these partitions because they were created under a Linux environment, which is okay. I'm going to select the primary, new, apply, implement. Very good. I've got all the primaries in play. Next. And it is now beginning the process of booting the NVMe drive. Rock and roll. Now, there's still a problem here that might happen. It's happened before. I could see the drive, I could format the drive, I could install on the drive, but when it came for the UEFI boot process to engage, it would deny seeing the NVMe drive as a bootable device. So that may be my next headache, unfortunately, just as a heads up. But this is good, because it just copied 4,400 files in a span of 20 seconds. It's fast, to say the least, right? So that's a good thing. So, with that being the case, I can then transfer the 2022 OS over to the clean 2019 install and wipe it clean with a 2022 installation, and I am good to go. So, I do maintain both principal environments of Linux. I used to do Linux, Unix, and Microsoft, but now I just do Linux and Microsoft, because Unix is pretty much kind of de-evolved, and Linux has become much more adaptive. So I use Mint Linux on my operating system to give me what I need. So, okay, in a whopping 12 minutes, it installed 2019. Now, 12 minutes for a 35-minute normal deployment on spinning disks. That's saying a lot. And that was NVMe. Now, the SSD drives have not been used yet. So they're not even present for use. Not yet. So, we're still going to find out how this is going to work out. The system is rebooting right now. Crossing our fingers, hoping that the next step is going to reveal to us that we are able to boot to the NVMe drive, which would be a big success and help me identify the processes that which it's gone through. Now, the only thing that could come back and get us is the UEFI interface may not still have the drive registered as a boot device in the key and have an encryption key for it and all that good stuff. But right now, I'm not going to touch anything, and I'm going to see how well the BIOS inherits. That's an important detail, because once this guy boots up and is functionalized, then I can add devices into the equation. And by doing that, I'll be able to get myself to a point where I'm able to put a whole hell of a lot of disks on this array. Both layers of SSD and layers of spinning disk. This is what we call HSM. HSM is hierarchical storage management. It's a term we used back in the 90s. I'm sorry, not in the 90s, back in the 2000s, as in before 2010. And it allowed us to basically run the pools in teams. All that data that was being accessed at a specific time period would have a certain response. That response, being fast, would ride on the faster disk. Now, back in the day, that was SAS and SATA. There was no SSD. It was all memory, SAS, or SATA. But with that being the case, you could do some pretty impressive things with it, because you could have a whole heck of a lot of data, but on a whole heck of a lot cheaper storage. So that was the goal of HSM. With this environment, we're trying to see if we can make the system use those old ways to accept new hardware. And if it can, then we thought outside the box successfully. If it doesn't, I have to go back to the drawing board and try again. I have had some research done and confirmed that some people have gotten NVMe to work. But it might be driven on the fact that the NVMe had a controller in front of it. And the controller is what got it accepted, not necessarily the NVMe state. Because that can be a little bit of a challenge, basically. So, like I said earlier, I have not touched any of this. The UEFI, I really want to see if it can do this autonomously. And if not, then I'll go in manually. And if I cannot do it manually, then I've got to go back and start over. So, with that being the case, we're now beginning the process of getting this to post. CLCA has come up. We've got firmware warnings that the machine has been offline for a while. Of course, it's a brand new motherboard. Okay. Let's see what happens. It should now post. I can see the drive lit up on the back of the chassis through the back port. Okay, firmware life cycle is coming up. It's the progressive bar going across the bottom. Life cycle is confirming that nothing has changed. Let's see if we can get the bloody thing to post. Now, while this is going through that process, one of the big reasons why I want an independent controller to be able to function beyond the capacity of the server is because when the server is using the RAID controller and the HBA controllers and the operating systems involved, there are resources that are committed that take away from both controllers. So the goal there is, if you really want good performance, with SSD drives, put multiple controllers on board, and you'll be able to put less SSD drives on the controllers, but you're going to get the maximum I/O from the controllers that they can handle. So with that being the case, when I want the NVMe cards to do what they need to do, let's see, Windows Boot Manager failed. Nope. Okay, so let's go into, oops. Let's go into F2. Okay, boom, Boot Manager. I'm checking the BIOS right now to force a sequence configuration. Alright. The extender is now in play. Let me add an extender here real quick. Give me a second. Okay. So we will try this again. Try again. Okay, so I've initiated a reboot. I'm going to go back into BIOS again. Now I've changed it to BIOS state. And I'm going to see if I can get it to post. Now, the problem with 2019 is it comes in two flavors, basically. I'll go into here. What the heck? Well, that's a pain in the butt. I'll reboot it. The drives are not going to be configurable. Alright. I removed the SSD drives so they won't interfere. The 710p is definitely blocking the SSD drives. It's got an instruction in it in the BIOS to treat all SSD drives as cache caddy. And to probably force the RAID controller into HBA mode. And see if I can get it to talk that way. Stand by for just a second. So as a side note, I had actually didn't realize the 10 gigabit network card that wasn't properly seating right, so it wasn't giving me the right responses. So I took a minute to just pop it off and put it back in place to hear that good old-fashioned click sound that I like to hear. But right now I'm going to go ahead and attempt a boot process here and get us up and running and take it from there. Stand by for a second here and I'll get us back into boot mode. Now something you need to hear real quickly is down here you don't really hear much from this unit. I mean, it is incredibly quiet right now. It's running on performance based on wattage, quietness. It's one of the reasons why I really like this server. I noticed with the server old motherboard that it was having pitching variances. I could hear the heat throttle effects happening and go woo, 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 like that. And that's an indication that there might be some problems with the thermostats on the board. So basically, we cheat. In other words, we go in and we begin the process of looking and trying to figure out where they are. If embedded, then we just simply have to replace the motherboard, which is what I eventually did. Between a bad DIMM socket and the thermometer issue, I decided it was time. Now my TrueNAS platform, which is also an R720-DX, it has already received a new motherboard years ago, and that was worked out really well, by the way. And it was very functional in its role and responsibility. So with that being the case, I was very pleased with how it performed in dealing with what I want and how I want things to work out. So this motherboard is panning out to work, in my opinion. Couple of hiccups, nothing major. Now we're going to go through the ever long, wonderful cycle of the life cycle process. All right, change of plans. We got a post call error on the UEFI emulation mode. So I was like, oh, that's grand. That's not good. So I had to jump back out. And I'm going to reconfigure the RAID controller for a traditional model deployment. Purge it, clear it completely out, and then reinitiate it again to allow me to get to the next level. Now, with that being said, the challenge here is I think the card configuration is still holding values locally inside the RAID controller itself, and that's why it won't clear correctly like I want it to. And this is not something that just happens naturally, especially when during the time SSD drives came out, this motherboard came out using SSD drives strictly as cache. So I have to do some enumeration effect here to get things to clean themselves up correctly and just purge the controller completely of everything it had, because that controller did run all of these disks in different configurations, and it still shows them as inactive, but they belong to a RAID set, and that right there is enough for me to say, okay, cool. I have to address that, because if I don't, it's not going to do what I want it to do, and that is to run SSD and NVMe. So what I'm going to do right now is I'm going to go in here and change a few things just to make sure that we're okay. Plus, I'll go ahead and save that. Give me a second. All right. Go down into device management. Device management is where the RAID controller is sitting. So I have to give it a minute here. Or two. Hopefully you're able to see this somewhat. It's very CLI-ish. I'm sorry. But I've been told, try to film as much as you can. So I'm doing it. It's all good. Alright. So we've got our NICs here. I got my 10 gigs, my two 10 giggers, and my two 1 giggers, and my RAID control. I'm going to go into here, and I'm going to basically check to see if we have anything out there. We've got cache, right? Right, okay. Manage virtual groups. Only one present. Right, RAID 1, that's correct. View attributes, there are none. Reconfigure, which I could do, but I'm not. So with that being the case, I'm going to have to now go down into the physical environment and pick a drive, clear it, start ops, confirm, and initiate. Takes a second. Done. Go up here and do another one. And by doing this, I am able to bring these drives out of their foreign configuration sets and turn them around and use them for actual use. This is a process, unfortunately, sorry to say. And but this is the unfortunate, tedious process of working with disks over and over and over in such a way so that you have to rebuild your functionals. Now, 0011 is obviously hitting on a good point, and that is the fact that we are working with configurations that are basically, as you and I would call, set in a way so that you can turn around and do certain things. Integrated array controller per controller configuration and virtual error message. Okay, cool. All right, apply back. Go back in. All right, I got that. All right. All right, so I don't have an initiation, and I don't have the ability to do triggers. So with that being the case, I'm going to have to jump back out. That's all right. I've cleared the drives. I can now build what I need to build, and that is going to be the way I want this system to work correctly. Of course, I'm going to have to reboot completely because it's going to be a pain in the butt. So be it. Reboot. And we'll go back into the BIOS and we'll be able to do things after that. Now, one thing I am going to do before I go back in the BIOS and tag a volume is I'm going to tag first my hot swap drives and then my alternate state drives into a RAID configuration, RAID 1. And that will allow me to get the machine to post into a somewhat of a normal state, basically. But it is a process. So we're rebooting now. I'm not going to go into the BIOS just yet. What I'm going to do instead is I'm going to go into the RAID controller and set my hot swaps up. Since all I've got on this bus is 1 terabyte drives going forward, I'll set both hot swaps as 1 terabyte baseline. So that will give me what I need. My external SAS controller sees nothing because it's not connected to anything yet. Stand by for a second. Okay, so we've got it coming back up now. I had to cycle the power on it. And we're coming into the RAID controller's BIOS. And that will give us the ability to set the hot swaps. And you do want to have a hot swap environment, and you do want a RAID 1 redundant model for your boot OS, regardless of the size of the operating system. By doing it that way, now you have a system that's fully redundant. Dual power supplies, dual SMP motherboard, processing and RAM, dual disk, dual failover, and hot swap state. So those variables coming together do allow you to have what we call an operations quality level server. Now, as an example, if you look back here, you'll see there are two drives back here. These are the drives I'm going to tag as hot swaps because it's easy to get to them and I don't have to mess with the front. I'll be able to get what I need to have done. So with that being the case, we're going to be able to go through the process of setting the system in place so that I have that full redundancy. What you do with your remaining disks is up to you. And remember that I have a SAS controller interface to connect to a whole heck of a lot of disks. And if I chose, I could walk the disks from chassis to chassis. For instance, I could walk the SSD disks on chassis 1 over to chassis 2 and then feed back through that same channel back to the controller. The problem with doing that is the fact that you have doubled the I/O against the controller. And yes, the controller is your bottleneck when it comes to SSDs or NVMEs because they perform so much faster than the traditional SAS disk. So what I would recommend instead is you run one SAS configuration strictly for SSD and the second SAS configuration for your SAS and SATA, your pseudo-fast and somewhat fast platforms. Okay, so now we are booting up into the environment. And we're going into the NIC. And we are going to now start building. We are going to create. But before we do creation, I think one of the key things we want to do here is understand how that's going to work. So before we do that, let me back out of this. And I want to see if I can create the swap drives on the fly. I don't think I'm going to be able to. Yeah, I don't think so. Because these last two drives I want to state. Oh, I can. Okay, I stand corrected. I'm going to assign it to the hot swap state, which is very good. Okay. And then I'm going to go in and do the second one. And I'm going to assign that as a hot swap. Very good. All right. Then I'm going to be able to do both of these functions right now. Now I can go in and create my boot configuration, which will be RAID 1. And I'm going to select the disks that I want. All right. That is done. Apply attribute. Agreed. Go down into here and enable caching. And I've got the environment created. So now I can be able to get this environment to a point where I can get a UFI, UF, whatever it is. Jeez, I hate that stupid term. But anyways, we're going to step back, go back to the setup environment, and may be forced to go back into the BIOS again and qualify yeah, I'm going to have to. Okay. So, unfortunately, I'll have to reboot to allow that to take effect. So stand by for a second here while I'll let it repost. Okay, so the configuration worked. The setup is clean. We are now going to attempt to see if I've got the ability, which I don't. So I'll have to check that out, find out what's going on with that. Come on. Okay. Nope. Okay. Alright. If you learn how to do OS boots without mouse functionality, that's fine. We can do that. There it is, it's back. I'm going to go down to that. And we'll accept the terms. I'm going to clean up all these old configurations. You do not want an inherited installation to cause problems. So we're going to go with the 1 terabyte drive. And I'll apply it. And create its own partitions. Now we're ready. Interesting enough, the NVMe component does register, as you'll see, but it's not bootable. We'll let it run through the process. I'll go ahead and pause it because this is pretty boring stuff here. Okay, so the Windows 2019 installation is completed. And we're now going into the process of allowing the platform to walk through. It does see the virtual disk, which is what I've created. Plus I have the hot swaps in effect, which are responding correctly. Plus the SSD drive is acting as cache caddy mode. So that's been addressed as well. So basically this is a truly fully deployed R720-DX platform. So the next question is to see if the UFID or the UF, whatever it is, the stupid BIOS locked style boot process is going to update this record correctly or not. So we're going to see what happens here in a second once it gets through the lifecycle manager. Now, to effectively build a server that is an operations level quality server, you can do it two ways. One, you can get it from the manufacturer ready to launch, which is usually just standardized and configurized. That's not great. It works, but 99% of the time, I'll wipe it clean. The reason why I wipe it clean is because I only want certain tools installed. I don't want all of the crap that different providers sometimes install. I want to have a lean, clean environment. Now, if you're in Linux environments, you also want a lean, clean operating system. It's to do a lot of the functionalities that you want, so basically you don't have to screw with anything else. Now, that works to a point, but the Microsoft environment also has a lot of value to the equation because they wouldn't be successful if they didn't have a good idea of something here. And that I am in concurrence with as well because of the fact that when you're in the environment, you're going to build out a clean system. You want to make sure, if you're truly doing this the right way, you want to make sure there's nothing inherited on your system such as remote access rights and things like that tech support does put into servers and even desktops and laptops so that they can better do their job. Got it? No thank you. That's a vulnerability that you've created and placed on my system that I may or may not be aware of. So it's easier to do a clean build and only add what you need to add. And that's the key detail. Now, if you look over here, you see the Windows icon coming up. So basically, we are successful. Not as nice as I wanted it to be, right? But that's okay. Now what I have to do is I will have to go in and type class all of my disks. These are the type classes I'm talking about. They basically have 3 generations of 1 terabyte drives that they will work with each other because they are all 1024 base terabyte drives. And as you can see, this is a Dell 1 terabyte. And as you can see, this is a Seagate authorization Dell hard drive, 1 terabyte. And then you've got the Hitachi variation of the 1 terabyte drive. And they're all basically 1 terabyte drives. But they're all of different kinds of configurations. And just as an example, once again, I'll show you this. This is an SSD drive. It's only 100 gigs. But remember when I talked about heat? Well, this is a little tiny data card right here. And the rest of this is nothing but a heatsink. They did it right. This is the right way to do a hard drive. If you're going to have to use the 2.5-inch format, then use it right to really make your SSD drives last as long as possible. And yes, servers can burn up the SSD drives. Now, when you compare this 100 gig SSD drive to this SSD drive, and you notice the thickness is dramatic, then please understand why I keep always saying, why didn't they put heat sinks on this? Well, because they want you to use these and keep buying more of them, opposed to using this for like 10 years. So, anyways, with that being said, and I digress, I have basically set up an environment where I have the disks in a foreign configuration. These will all have to be built out, and this will give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 terabytes of capacity at 10,000, at 15,000 RPM, and which is excellent. And I'm not going to use this SSD drive. I'm actually going to keep this out and just show it off to show people what an SSD drive with its cooling system really looks like. And, they did it right. There's a reason why certain drives cost a fortune and other drives don't. This, $20. This, $300. There's a reason. Anyways, I digress. So with that being said, I am going to start to work into this configuration, and I'll build this out. As you can see, the front of this chassis is gutted. It's pretty empty, right? There's like lots of space in here. And yes, I do have the drives out, and that does make the workload unstable. But the good news is that in time, I'm going to basically wipe the configuration and rebuild it into a more functional environment and allow me to get things going. But until then, this machine is going to run really low RPM. I'm not going to task it. Not yet. But I do always run in parallels. In other words, I always have 2 sources of my requirements. Those 2 sources are very important, because if you don't do it that way, then you can have a real kiss of death here. You have to understand that people really want to invade your privacy. They make money if they can. And your data is important to you. So it's always important to have your data in 2 places. 1, your usable platform, where you can access constantly. And that needs to work well. And 2, a platform that's not accessible, that only comes in periodically and does a couple of things, right? And then steps away. So with that being said, understanding that security and implementation, I'm going to be going into some very significant videos about that. Might be a little boring for some of you out there that love hardware, I'm sorry. But now that you're actually accomplishing some serious significant functions, you need to get up to speed with some of the other functionalities, such as cloud ops, DevOps, SecOps, FinOps, Security Control Ops, or known as SecOps. And these are ways of thinking that help give you structure to the old ways of, well, I just implement a couple of security features and I'm good to go. Well, that's a lie. So let's not lie to ourselves or to anyone else around us, right? And just understand that the truth of the matter is, with everything in game and the way we do things, it's important to understand our limitations, understand what we can accomplish, and then get better at it, right? So I'm a director of DevOps. That's CI/CD implementation. That's continuous integration and deployment, basically, or continuous deployment. I'm also a director of operations, and it's about thinking ahead. It's about thinking today, and it's about being prepared for what might have happened yesterday. And as you're getting better and good at this stuff, you need to start advancing your levels of administration, of management, of time management, and so on and so on. But for now, as you can see here, we've logged into 2019. I'm going to go ahead and upgrade this to 2022. That won't be a video I'll do. I'll do that maybe one day down the road. But for now, I'm focused on getting the environments to an operational capacity so I could, have my two sources of data and so on and so on. But for an hour plus video, this is a pretty long one. I apologize for that. If you dropped, I get it. But if you don't, I get it. I appreciate everybody out there, and I will let you go. God bless and take care.